Welcome back to my channel, and thank you for guys for tuning in to week 9, I believe this is, of the Career Progression Bootcamp. We get ready to just check the stream real quick, make sure our audio is good and everything. All right. So if you guys are new to the channel, if you're into tech, entrepreneurship, coding, or startups, anything like that, make sure you guys like, share, and subscribe. That's all we talk about here on this channel. And this live stream is basically where every week myself and some other professional software developers who are working remotely on studying together and just pretty much showing and sharing how we get better, how we progress our skills, and pretty much learn new things while we work, while we're on the job. And we do everything remotely, and we try to just share as much as possible with you guys. So if you have any questions about anything that we're going over, make sure you guys drop it down in the comment section down below, and we'll be sure to get right to you or as soon as possible. So I'm gonna go ahead and call in La right now, and we're gonna go ahead and kick this week off. We got some good content for you guys this week. So yo, what's going on? I'm about to go ahead and share my screen and jump right into it. Let me real quick. There we go. Select all. Let me see. Let me see. Select all. Okay. All right, there we go. I got you. All right, my bad. I had to get you on the YouTube stream. I had you on Skype, but all right. So all right. Share my. Where is it? There we go. Alright. Pull this over. Alright, cool. So now let me know when you can see my slides. If you can see it on YouTube.
Alright.
Yep, I think we should be good. Yep, I see it. Alright guys, so this week I had a pivot like midway through the week on what I was going to be sharing with you guys. I thought I was going to come in and talk about Redux stuff, but I'm still working on that. So in the meantime, I was working on creating a service that basically helped me send out emails to people, and I was paying like $30 a month for the service that I was using. And this is let me see. This on the screen. This is basically going to be just what SMTP is. SMTP stands for Simple Mail Transfer Protocol. Excuse me, guys. And I'm gonna be showing you guys how I ended up creating a simple web API that allows me to send emails using C#.net. So SMTP is one of two main protocols that allow us to send and receive emails. So SMTP is used for when we send emails, and then IMAP is used for when people actually open our emails or when they download things. SMTP is what your email client, so it could be like Gmail, Outlook, Thunderbird, whatever client you want to use, they will use SMTP to send your emails to your email server. So from there, SMTP is also used to send emails from the email server to the inbox of the person you're trying to send your email to as well. So all the way from when you compose the email on your local, machine, when you log into like Gmail, Outlook, whatever, when you type the email up on your computer, and you press send, it uses SMTP to send it to the other person and also find the other person's email. So it'll look up the address of the person that you're trying to send the email to. And there's going to be more on this in a couple slides. But SMTP protocol looks up the address that you're trying to send to the recipient. And then if it can find it, it guarantees that it'll deliver the email to that address specifically. So all the way until from when you push send on your computer, when you write the email, all the way until it lands in the recipient's inbox, that entire process is using the SMTP protocol. And then you use the other protocol when people are like downloading attachments or something from your email, which is exactly this right here. So from there, the recipient's email fetches your message and uses IMAP, which is Internet Message Access Protocol, and puts it in their inbox where they can access it. So this is an actual flow, like a chart of what we were just talking about. So I'll move this out of the way. Probably up here is better. So here's where we start when we type the email. So this is where we're like using the browser. We're logging into Gmail, Outlook, whatever up here. And then when we send the email, it's going to use SMTP, go to an SMTP server. And ISP stands for Internet Service Provider. So your Internet Service Provider's SMTP server. And then again, we're going to use SMTP to send it to the recipient. And then it's going to go into the recipient's mailbox. And then from there, they'll be able to view it in the browser, or they can use IMAP at this point to download like attachments or anything. Basically the content of the email. If they want to actually download it, that would be the IMAP protocol. Alright, so let's see how this looks and works in C#.net. So when I first started doing research on how I wanted to do this, I saw a lot of documentation from like anywhere from 2018 and like 2018 and previous, so like 2017, 2016, and all of it was using this class right here, this Microsoft class, SMTP client class. And so all the examples that I saw, all the blogs, like everything was using this in order to create basically this class takes care of all the things that are required to send an email. So when you send an email, there's under the hood, there's like a lot of things going on. There's like a date being attached to it. There's like we said, there's addresses being sent. There's a bunch of data, like metadata or whatever, that goes into the message itself. We end up putting like a subject, a sender, who we are, who we wanted to go to, the subject and the body or whatever of the email and any attachments. But there's a lot more data that goes into the SMTP protocol when we send the email. So in C#, and I'm sure in most languages or whatever, there'll be some sort of class or something that helps you basically do that or abstracts that away, so it makes it really easy for you to send the email. So all the documentation I was seeing was using this SMTP client class. But as you guys can see here, there's a warning right here that says this API is now obsolete. So even though all the documentation is still here and everything, this was definitely a sign that I probably shouldn't be using this. Anytime you see anything that's obsolete or deprecated, it's no longer being supported. It'll likely break, or it's been compromised, or it's been hacked, or the developers found something better, they created something better, or there's a better open source library package or something that you should be using in that sense, in that case. So in this example, I was looking up how I wanted to implement the service, and this is the first thing I came to look up, and this is what I saw. So I had to find an alternative basically to SMTP client. There wasn't a ton of documentation, but I ended up finding what is the new standard for C#.net for sending email clients, and it's this. So it's a NuGet package called MailKit. So you can go look this up, do like a Google search or whatever, but if you're using Visual Studio to develop C#.net applications, you can just go to your NuGet package manager and just type in MailKit, It'll be the first thing that pops up. It's the one that's highlighted here in the example. I'm using .NET Core 3.0, so it worked just fine for me. There's another one that actually is called MailKit.NET Core, and I tried it using both packages, and then I tried it with just the MailKit one, and it works just fine with .NET Core. And I'm using Mac as well, and it still works fine with just MailKit. So you don't need the .NET Core version for anybody that is thinking about implementing this. But this is the one that is the new replacement, and they also have an SMTP client named the exact same thing as this deprecated one, named the exact same thing, except it comes from this NuGet package, MailKit, not this one, the Microsoft package that comes from system.net.mail. So interesting how the replacement is an open source library called MailKit, but the SMTP client that you're going to be using from MailKit is named the exact same way that the deprecated one was named. Just to, make it, I guess, easier for anybody who has to switch over to MailKit. They kept it named the exact same thing. So this is one of my controller methods in my API, and this handles all the functionality for sending the email. So let me move this out the way a little bit. This handles everything. So I'm not doing anything in my app configurations or anything like that. All the code is being handled here. Anything that throws errors in Visual Studio, like for example, when you instantiate this new iMessage or this MIME message class, this is coming from MailKit. This mailbox address is coming from MailKit. And again, SMTP client is also coming from MailKit. But when you write this out in Visual Studio, it'll throw an error. So you can just go ahead and hover over the red error. It'll allow you to import all this stuff from MailKit once you've downloaded the NuGet package. And this is all we're doing. So this MIME message is the email. So when I was telling you all that extra metadata that is required by the SMTP protocol, it all comes in this MIME message class from MailKit. So you create a new instance of a MIME message, and then from there we can just add who the email is going to be from, who we want it to go to. So you can see that message has a from method, has a to method, has a subject method, has a body method. So it's that simple to put it all together once we are using MailKit and have a MIME message instantiated. So we just go in, and then right now I have these values hard coded. I'm working on right now a React front end where I can obviously dynamically pass these values over. But so this would just be, again, the person who the email is going to be coming from, or the email address credentials of who the sender is going to be. This is who it's going to go to, the subject. We have to specify what kind of text, so we're going to use plain text, and then we'll just hard code in the text for the email right here. And then all this is right here is just the syntax for actually configuring our SMTP client. So again, we need to make a connection using the SMTP protocol. So we need to connect. So you can specify any sort of email server here. So this could be smtp.gmail or smtp. What was the other one? Thunderbird, whatever you're using for your email service provider. This is the port number. So you can always look up what port does Outlook run on, or what port does Gmail work on. So this second number right here is the port number, and then I believe this is specifying something related to OAuth, and you can just say false if you don't want it to require OAuth, because I had an issue using Gmail with this because Gmail by default uses OAuth, and so even if your credentials were right, or if my credentials were right, my request wouldn't go through because of that. So that's actually why I'm using Outlook here, is because Gmail gave me a hard time. You have to go into your Gmail account and configure your settings and stuff to allow applications to use your credentials to log into your Gmail to do stuff like this. So it was a little harder. So then we authenticate with our credentials. So obviously this right here is these are not real credentials, obviously, but this would be, so if you have an Outlook account, this would be your email for that Outlook account and your password for that same Outlook account. And then we can just say client.send and pass in the message. So it'll be this entire thing here, as well as all the stuff that comes with a my message. Like I said, it'll be like a sender time and all this other like metadata about the message. And then we have to disconnect after we send it. We have to disconnect the connection. And that is literally it, guys. You can see this is annotated up here, just like every other request in a C# API by the HTTP post. So we can just make a post request to this. And you can also see that we're not passing anything in right now because all the data for the email is hard-coded. So I don't have to pass anything in. So then all we have to do is go here and make a post request to, this is my path, so API/email service, and make a post request. And you see that we get a 200. And then in my email, this is how it comes in, first email attempt. And then if we go back, you can see the subject was first email attempt right here. And then the actual body of the email, this was sent from your C# email service. And the body of the email was hard-coded to say this was sent from your C# email service. So this is literally it, guys. Like, it was so straightforward. Just a very good lesson, and this is obviously very extensible. So I'm going to be using this as a microservice. I plan to like integrate this with another application I'm working on, and I want to build this out too because, like I said, I was paying like $30 a month for an email service, and with literally just this many lines of code, not even like 40 or 50 lines of code, I can at least be sending emails out, and then all the other features I can just work on in this microservice. So the summary for today pretty much is, think of SMTP like a mailman. Mailman picks up the mail from your local computer or from your home, and then I guess from the post office would be a little bit better, but the mailman would pick up the mail and they would look up the address or the location of where it needs to be delivered, and then they go deliver it. So that's pretty much SMTP in a nutshell. And then when you think of it, I thought this was a cool like little tip or acronym, but sending mail to people. Obviously it stands for Simple Mail Transfer Protocol, but you can also think of it as sending mail to people, which I thought was really cool. So once the recipient gets the mail, they can use IMAP when they download the content of the email, if we have any attachments or anything like that, or if they just actually like download the email itself. Otherwise, the content is viewed in the browser. And then let me move this out the way. And then last thing we talked about is that libraries and packages that are marked deprecated or obsolete should never be used. We should always try to look for documentation that shows the most stable replacement. Usually it'll be like something open source, or try to find some sort of alternative. So that is all I got. La, you still with me?
Yes, I'm still here.
Perfect. Alright, cool. Any thoughts on that?
It was pretty good. So how did you like it? How did you like working with the system?
I like it. It's really straightforward. So now one of my things is I'm working on, so I got the front end, I got a form on there in React, and I'm able to get all my data or whatever. I'm able to send it. But the thing about it is, when I am trying to use, like, I make a model for an email that has this my from, my to, my subject, and my body, and then I try to pass in that model in the post so that you can basically use the form and then send that data over, and then you can basically just dynamically fill out the email. For whatever reason, that comes back as null, like state comes out as null for some reason. Where I can see all the values, in the console. So when I console log state, everything is there. But when it goes to actually send the email out, it says that the email model that I made is null. So that means I have to pass that MIME message. I can't just pass a made up email model. I have to actually pass that MIME message because it has everything for that SMTP protocol. So now I'm trying to just play around with that and kind of figure out how I can just substitute some of the values and not necessarily have to pass a whole mind message, because I don't want to send all that. I should be able to just, and when I tried to do it, it was just giving me issues. So I'll show you after the stream, but it's interesting. But yeah, it was very straightforward though, very straightforward. So on yours, we're doing the operating systems one, right?
Yeah. So we go to chapter 3, processes.
Okay.
Still up. Not too far behind you. So yeah, so I'm gonna probably try to keep it more like a conversation. I pulled out certain pieces that I thought that would be really relevant for the things that you and I have been talking about over the last month and a half. But I thought it was pretty interesting. I'm gonna try to keep it in the forefront too, meaning that there's some knowledge I have about some things, but so far reading my my book, it only talked about it in this form. So I'm gonna just follow the book and follow, the knowledge as they give it to me. But so processes. What was very interesting about I guess processes for me. I guess we could move along if you would like to the next slide. But what's very interesting about it is that a process is just pretty much a program in execution. That's pretty much it. Just one program in execution is a process. For right now, for the purpose of our conversation. I think it's very interesting because it talks about the fact that only one process can run on your system at one time. So I thought that was interesting. Even in the sense that I know that there's such things as dual core systems, and you have multi-process operating systems. But just trying, I guess, stay where they were, talking about it. Just one process can operate, on a system at one time. So I thought that was pretty much interesting. So it says pretty much like a process. It has like I lost it. Sorry. There we go. A process has like is a stack. Like it has a stack that it follows, and well, I won't say it follows, but I guess I thought of this more like how we think about the headers when we talk about networking and how we pass information along. But every process contains this information where you have your function parameters, your return addresses, and your local variables. In your data section of it, you have your global variables. So it also may include, they say, like a heap or memory. So I thought that was interesting that, we talk about a process as a program and saying that with that program, all these things always go along with the program: the function parameters, the return addresses, the local variables, and the global variables. And a heap, I guess, memory, or, memory, or how memory is going to be allocated for this program per se to run. So I thought that was interesting. Then they talked about a process having state. So that became even more interesting because, I work a lot in React. So just the concept of a process having state. So, still keeping in my mindset that a process is just an application, one single application. This application can have state, whether I'm starting an application, so it's being created, whether the application is actually running. And when they said running was really interesting too, thinking about, I think about running, thinking about me interacting with the application. But I guess in this terms, when they talk about running, they're talking about it from the standpoint of your process actually reading instructions that need to be executed. So that was interesting. You talk about waiting when it said process waiting for an event to occur. So that's pretty much standard, whatever. Being ready, and terminating. So I just thought that was interesting, just thinking about the state of a process and where a process is and how it sort of moves along. I guess its life cycle, I guess you can say. It's very interesting. I don't know. We can move to the next slide. Oh yeah, I'm sorry, you're behind me. But yeah, I can't. I gotta go. I can't. I do know my next slide is. I'm sorry.
Yeah, no, you're good.
With me.
We're on process block.
Yeah, process block. So I thought this part was interesting too. So we're still talking about this application, this process, and we talk about how the things of a process, and we talk about a block. So I don't know if you're familiar with a block in like programming languages. When you think about a block, it's just like
Yeah.
a short, I guess a couple of statements of code, you know what I mean, that's wrapped in a function or a method or a call, however you look at it. So when you think about a process that it has a block. So in addition to these headers, I guess I look at, it has this block, and this block has certain information about this particular process. As I'm listening to this stuff and reading about this stuff, it just started to make more sense because remember, we just talked about networking, we talk about everything else we talk about, and this is sort of the same type of information that goes along. So in this process block, it contains the process state. So wherever this process is going or however it moves, once we talk about that moving forward, it has a concept of where the process is, what's the state of this process. It has a counter. They keep track of how long this process has been open or been running. That's interesting. It has a register. That's the memory, and what's the memory going on with it. Scheduling information. I'll tell you more about that as we move forward. Memory management information. How you manage the memory of this application. Accounting information. It's interesting to me that all computer programs are always built in with this concept of paying for the time. So there's accounting. It keeps track of how long you've been. It takes that counter and comes up with a cost. Amount of cost you've been on the program for.
I hear that all the time, yeah.
Yep. Then the in and out status information. Just pretty much your in and out outputs are pretty much how we sort of communicate with the application. So it keeps track of that. And all this stuff is kept track of in a data structure in C language called a struct, which I thought was very interesting too, because I know struct from C, but I know it more so too from Solidity. If you think about it in typical program, I guess in your program, it'd be sort of like a hash, and in JavaScript it'd be an object. Not so much of, but a little bit like that, you know what I mean? But so they keep all that information in a struct, which is really pretty much captured there. It moves across to this process scheduling. So process scheduling is how those instructions I talked to you about. So if you have an application, convention says that an application has lots of instructions. It's not going to just have one instruction. It's going to tell you to do this, then do that, then do this, then do that. So as you're moving along with your processes and all these instructions, you need to keep track of where your process is and what's the next process to be done. So once this process is finally over, you might have another process that needs to be open, another application. You need some way of the computer keeps track of this called process scheduling. And what was interesting to me about this process scheduling was that the process is in there, which consists of this data structure called a block. And this process scheduling is captivated in a queue, which is held in a double linked list. Because you need to keep track of the process that happened behind you in case something interrupted on your system, and you need to go back to a process. So knowing the double linked list, you keep a pointer on what's ahead and a pointer what's behind, and you know what you're doing right now. So I thought that was very interesting how I talked about that as we were going through this whole how applications run on your system.
Next slide.
Yep, next slide. So the next slide talks about the queuing diagram. And this is talking about how those processes are kept in this queue. Again, all these processes, you have some long processes and some short processes, but bottom line, they're all kept in different queues. So, and if you think about the operating system, like we talked about before, and the input-output systems and the device management systems and memory systems, pretty much what this session talked about was that every system operates based on a queue. So whatever process that system has, it still operates on these queues. And pretty much talked about it like, I guess in the diagram where, you have your ready queue. Remember, your ready is a process state, meaning you're ready to go to the next process. You move from that, to this little, to your computer, to your operating system. You travel down, And if you have an in and out request in that process stack, remember that stack has the instructions of what's to do next. If you have an in and out process, then you slide into that queue and you slide into that request and you do that same thing for that sort of slot there. And you continue to go down into these different ways. We'll talk about the child as we get later on and wait for the interrupter. Like I said, if the system interrupts, then you have to stop where you are right now, keeping a pointer on what happened before you. So in case you need to automatically stop and start back up, you have where you were before and you just pull it back up from before there. So that's pretty much how this queuing diagram works. So I thought that was pretty interesting too, because again, it still focuses on our data structures and how everything is operating based on these data structures. Next slide. So this slide was interesting because we go to the concept of this process creation. So it was interesting because it talked about that a process, and then you think about React too, you think about this, I guess you can think about all kinds of things. You think about a tree. I mean, that's typically where this really comes from, a tree, honestly. But so you have your initial process. Remember how I said in the beginning that they said that a one operating system can only manage one process at a time, no matter what, which seems pretty impossible, right? Even if you took out the concept of that, we have dual core operating systems now, we have multi-processing. We even took that concept out. So you only had a single core processing system. You still have multiple applications running on your system at one time, technically, right? So how does this concept make sense? Well, the concept makes sense because a process can have other processes. So a process can give birth to children processes. And those processes can do either A, can run other programs, or B, act as like a scheduler or a manager of processes. When I told you that process and scheduler thing, it could be a process that's responsible for managing or your other processes. And you can move these processes down trees and continue to have process after process after process after process. And all these processes are open until the top parent process.
So none of them are running at the same time. They're just in line.
Well, they are sort of running in the same time because they're running off their parents. Almost like you're giving birth to your child. So if you have a kid, if you have their husband and wife, and you have a kid, that's a triangle right there. You all are alive at the same time. You know what I mean? But so how it goes to what you're saying right now well, how does that make sense for a computer? Because the reason why we couldn't have all these processes running because we didn't have enough resources for all these processes. Well, that's where it comes to process management. And the concept of that, it comes down to, does the parent share their resources? And then when you go back into that block, you talk about that block also is responsible for resource management, where it talks about, okay, if I'm going to be a parent and I'm going to choose to share I could either do two things. I could either A, share my resources with my children, or B, I could have my children take the resources for the overall operating system. The problem with the latter one is that if you have your children take it from the overall operating system, is that you run an opportunity that you can run out of resources and your system crash because no one's controlling it, right? But if your parent controls all the resources, then your parent can divvy out and make sure that all your kids have the resources they need. And they also can divvy out and give more to certain kids based on what their responsibilities are, so forth and so on. This is all starting to sound like networking and Docker and container, right? It's all starting to sound like how they manage your processes, but this is the same way here. All right. So pretty much, I thought that was pretty much interesting because, So I thought that was pretty much interesting because, again, I thought because just the concept of the trees helped me understand how one process on a system can have multiple processes open, how you can have your system crash because you can run out of space, you can use too many resources that way. So that was very interesting. I thought this was also interesting too because I guess that's where the whole concept of the Docker containers or even AWS comes from. How when you go into AWS, you're sort of partitioned off, you're sharing part of the operating system with somebody else. You know what I mean? So definitely. I'm pretty sure. So it was very interesting. That was interesting understanding all that when they talked about the whole process creation thing. So we'll go down to the next slide, where I think that's our final slide. There were other things at the end of the chapter, but I'm going to sort of end here because I thought this is pretty much the most relevant stuff. At the rest of the chapter talked about examples of all the things we talked about here, but I just thought this was all the stuff that I pulled out was the most relevant things the chapter offered. But the last part of it was the inter-process communication. How do processes communicate with each other? So I thought that was interesting because when you talk about this, they talked about there was two main ways of doing it. Well, Well, they talked about why it's important to do it. We talked about, the whole Docker container talks about information sharing. If you want to do that, you want to, if you want to share resources of a computer like a Docker or AWS, it allows you for computation speed up where you can do things faster by sharing more of the resources. Modularity, breaking things up into little pieces so that everyone's stuff is contained and allows computer processes to run faster, operating systems to run faster because of that. Just pretty much for convenience. Why you want to have these you want to share your resources amongst your processes. But there are two main ways that you do it. You could do it in a shared memory system environment, or you could do it in a message passing system. What's interesting is that a shared memory system environment is very similar to the concept of an API. So you and I have, we watch basketball, football, and we have all this data, all these stats stored, and we have them all stored in one database. And so what we do is we want to share our information with other people. We want to share our application, our program with other programs. And the way we do that is to build an API, which is one single place. We have endpoints where everyone's able to hit those endpoints to grab all that information from that one shared memory spot. So that's very fast. It's very efficient. The problem is that you have to worry about collisions, and stuff like that. Because if a lot of people are hitting your shared API at one time, then how do you manage that traffic? And operating systems don't do that for you. However, that whole process of sharing memory or sharing space or sharing content or sharing data is a way of inter-process communication.
Yeah, because each endpoint is for a resource in the API, right? So
yep.
So yeah, I'm sure that has something to do with the management of your whatever the server operating system is.
Well, that's one way. I mean, I'm pretty sure when you think about it too, like I said, if we had a sports API, even if we had one endpoint manage different resources, someone still could overburden our one endpoint. You know what I mean? So if you think about most APIs, that's when they have things where they have limits, rate limitations for you, and they put blocks in you. Because of all that, that's where it's saying that the operating system provides a way for you to be able to do that shared memory and that shared, it's possible, but it's not responsible for managing the collisions or the people overly taxing your system. So you have to do that. So that's where it comes in at.
Got it. That makes sense.
The last way, the way that we all know, is the message passing system. And I feel like it's interesting because we always come back to this whole HTTP system, this client server communication system, and this is pretty much the other way the two processes, two programs can communicate with each other. You can send a message to client server. We could open up whether we do it through sockets or whether you do it through just a regular HTTP protocol where you send out a request and you wait for that request to come back with a response. That's another way for processes or programs to communicate with each other. Overall, as I'm reading about this, reading into this chapter, some of this stuff is a little daunting because we talk about all the time about how heavy this operating system stuff is, how it is. And interesting enough, just reading through all that stuff, it goes back to, I remember saying to you before also that this stuff is just a repeat of everything. We're just repeating the same concepts over and over again because anything I talked about today, I don't think that we haven't talked about in some way over this last month and a half. It's just interesting when you put it together in a chapter and relate all of what we do and help us understand what the words are, what the terms are, and why they're connected that way. It just gives a different picture of it, but we still have been talking about this information for the last month and a half, and whether it was networking, whether it was building whatever it was, we were talking about this information.
But I think that also goes back to why the fundamentals are so important, because all of it is using the same data structures, the same types of processes, design patterns. But if you understand that, then it makes sense why everything ends up adding up or coming together.
Yeah.
So that was good. Let me stop my screen share real quick. Cool. So yeah, I think that was really good. So was there more in was there a chapter 4 in there too, or did I?
It goes up to 12 chapters. So the next chapter is threading. Okay. So I'm interested in that because they only talked a little bit about threading. They didn't talk a lot about it. They mentioned about how it related to that they said process is the program that performs a single thread of execution. So they didn't really give me more information than that. So I'm definitely interested into, understanding, multi-threading, what all that means, and how does that relate to the whole concept of only one process runs at one time, and in order to get multiple processes, you break it down in a tree format. We have parent and children. So I'm curious to how all that sort of fits into it, because I think threading has a lot to do with concurrency. So I'm really curious to how that. So I definitely will. We'll keep you guys posted on chapter 4. I don't even know. I might even go to chapter 4 next week because I'm doing so much coding now. This might keep me in a reading bench, just reading something.
For sure. Well, thank you, La, for being on again 9 weeks straight and sharing that with us. Is really helpful. Thank you guys for tuning in and enjoying. Make sure you guys like, share, and subscribe if you guys found this helpful. Leave any questions for us down in the comment section down below. Be sure to get back to you guys on that one. And we'll see you guys right here next Sunday for week number 10. And then, La, I'll meet you on where, bye?
Yep, walk the dog first.
Oh, okay. All right, cool. Just let me know.
All right.
All right. See you guys. Yep.